This video will be dealing with two learning targets. You'll be looking at chemical and physical properties and also looking at chemical and physical changes. Basically focusing on how to distinguish between a chemical and a physical property and a change. So you see here pretty straightforward what a physical property is versus a chemical property. Essentially these are two different ways of looking at matter. Okay, we originally looked at classification of matter in terms of how can you classify what it is in regard to, is it an element, is it a compound, how is it organized? Okay, and this is another way to classify matter, but it's more descriptive in terms of what type of matter, what are the properties that matter has. So the first one is a physical property. Okay, a physical property of matter is anything that can be observed about it. So for example, color, shape, texture, taste. You can get into things like boiling points and melting points. And those are all physical properties of matter, things that you can simply observe and report about the matter you see. Okay. Chemical property, on the other hand, it's not something you can observe just straight off the bat because it has to do with the chemical composition of the matter. Okay. So it can only be observed when it's in interaction with something else. And essentially, a chemical property it's based on what elements are present in that matter. So the chemical property of water is based on the fact that it has hydrogen and oxygen bonded together. Okay. And we can't see the hydrogen and oxygen bonded together. The only way we know it's there is based on how it interacted with other substances, which is why we can't ascertain chemical properties simply by looking at them. Okay, you can't see the hydrogen, you can't see the oxygen, you gotta do something. So physical properties, straight up what you see. Chemical properties are mostly things that we discover through a laboratory investigation. The easiest way to tell the difference between a chemical and physical property in descriptors are kind of these words that are listed on this screen, okay? On the left-hand side, you have physical properties. So again, size, shape, smell, boiling point, melting point, magnetism, density, okay? All these things that you can observe and describe. Chemical properties, again, all have to do with reactivity. So common terms for that, whether it's flammable, whether it can rust, what the pH is, okay? How it reacted with water, how it reacts with oxygen, what kind of new product did it form. Okay? You see here that flammability and the rusting, those are two terms that we use in relation to a chemical change. The word dissolving would be under a physical property because it's not a chemical change. What happens when you change material? How can you tell if when you changed it on a physical level, or when you changed it on a chemical level? Well, if you change it physically, here are some examples of how you can change it physically. Okay, you can change its shape, its size, what state of matter it is. You could dissolve it. Those are all ways you change the physical property, but you don't change chemical property. Essentially what I'm getting at here is that when you take water, which is H2O, and you freeze it, it's still water. Okay? You put it in a new container, it's still water. That's a physical change. If you took H2O and you actually split it, so you had hydrogen and oxygen separate, that would be a chemical change because it's no longer water. Okay? You have something new. The big thing about a physical change is if you do a physical change, it doesn't change what it is. It's still water. Okay? So it's easily reversible, which is the question, can you get it back? If you did something where you can pretty much get it back because you just changed form, you didn't change what it was, that's a physical change. Chemical change, on the other hand, actually changes the chemical structure, so you create something new. And these are the signs that show you've created something new. Okay, if you make bubbles or a gas, that means you made something new. You made a gas that didn't exist before. If you create a solid, okay, which is a precipitate, the big thing about that one is what it looks like in a lab. If you make a precipitate or a solid, the solution gets cloudy. Okay? So if that happens, that's a chemical change. You made something new that wasn't there before. If you produce light, okay, that's a sign of a chemical change. If all of a sudden it gets hot or cold on its own, that's chemical change. And then if it changes color, like a crazy color, and not if you put blue and yellow together and it makes green. Okay, blue and yellow always make green. But if you put blue and yellow together and that makes red, that would be a chemical change. Increase and decrease heat, that often throws people because you can physically change something, meaning you can make water colder and it will change to ice. That's a physical change because you input the energy, right? You got it cold, you put it in the freezer. The increase and decrease in heat that has to do with the chemical change is that it spontaneously did it. You took two room temperature things and mixed them together, and all of a sudden it got hot, or all of a sudden it got cold, like it did in our introductory lab. If that were to happen, that would be a sign that something actually changed on a chemical level. Because when something changes on the chemical level, it can release heat or absorb heat just to change that chemical structure. Okay. So get familiar with these terms in relation to what is chemical and what is physical. And then in lab, you will actually conduct 4 different experiments. And from what you see, decide whether the change that we observed was a chemical change or a physical change. That's it for this video. Go ahead and do the form and have a nice night.